Hey there, CC friends. Welcome to week 8, unit 8, called Equations of the Math. So this one is really cool. I love how it brings everything together. Hopefully it feels a little bit like a breath of fresh air from the last two, especially the last one with exponents had a lot of very difficult math concepts, and this kind of brings us back. Now, some of this is naturally pretty still difficult, but it's I love just how kids are all the students are getting to see the connection of what are they learning, the operations, like why are we learning this at whatever level they're doing, even for the younger levels. My kids really enjoyed this. It was very appropriate for their age, the packet for the equations. My daughter doing my 8-year old doing the fractions program, and then my 5-year old doing the naturals program. They loved it. We actually did it together because there wasn't a lot of deviation for this one in the packets. And they just had a lot of fun with it. So I'm just going to point out a few things from the first 4 pages. As one who has a math background, I look at it and I see that a lot of it is straightforward in the sense, not that it's easy, but that, it's if you are following and looking at the answer key, a lot of it does make sense. And naturally, I understand, that's me. Others might feel a little bit more lost in the sauce with this, but that's okay. Again, remember, this is a whole new way of teaching math, but I just want to reiterate again how brilliant, as I look at it, just there's so much in here. It's just amazing. I love how they are relating, adding and subtracting is counting forward, counting backwards. It just showing all the different on page 1, it's matching all the different types of mathematical operations, even logarithms and some of the trigonometric functions that some kids never even get to learn. They're just seeing outside of the box that there is so much more than often what they're introduced to in school. So it's just a great basis that is going to help them in life. Then there's on page 2, I wanted to point out. So if you see, finding roots of quadratic polynomials, okay? So we're not going to go deep into this, but what is a quadratic polynomial? It is so we see patterns in math, and anything with this pattern, let's just keep it simple. We'll keep a real simple one. I think with this pattern where we have just x is the variable and we have all these terms. So I'll say it over and over. Terms are always things separated by pluses and minuses. Okay, so this is a term, this is a term, this is a term. This is 3 terms. We would actually call it a trinomial for 3. Okay, polynomial just means it could have any number of terms. If I just had an equation, y equals x, that's a polynomial. Okay, it only is a polynomial of degree 1, so we would call it a monomial. Okay, then you have a um I said that wrong. I said that wrong. I think it's not degree 1, but anyway, we're we're talking deep into math terms here. But anyway, you're looking at this. The thing that makes this quadratic is the 2. And there's a lot that could go in that could be confusing because you can talk about the number of terms you have in a polynomial, and that's when you hear things like monomial, binomial, trinomial, and then after that, it's just polynomial for 4 terms and above. But the degree of the polynomial is the highest power of x, the highest exponent of x. So this one's 2. So we call it a quadratic. So they are very, very brilliantly showing how do we find the roots of a quadratic. On page 2 near the bottom, it is showing, what that means. And I showed this in a different video is how can I work backwards? And this one's actually unfactorable, so I won't throw you into that. But how could I actually find the solutions to this problem? So if I have this one's in here, x squared plus 7x. There's my little mathematician in the making, about to leave for CC. If I have x squared plus 7x plus 12, hey girl, And I want to figure out what was this before I multiplied it out. I would have to pick numbers for here, 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 and here. So to get x squared in the front, there's this thing called FOIL: first, outside, inside, last, and that's the order. It's the distributive property, but we're just distributing the first term to both and then the second term to both, and you should come out with four terms. So it's called the FOIL method because it's a quick way to teach kids an acronym to remember. Shh. So my first two, when I multiply, have to be x's. And then what this shows is it's showing what are the x's, and this problem that it's giving is just really brilliant. And there's several of them, but they're working through, and it's showing them how in the middle, when these are both pluses, that means these are both positives. And I'll do a video on factoring, just its own separate video here in the next week or so. That way it makes a little more sense because we don't have time to go into it. But you want two numbers when these are both positive. You want two numbers multiplied together that equal 12, which we could do 1 and 12. We could do 3 and 4, or we could do 2 and 6. But added together have to equal 7. And it details that out. It's like sum to find b, meaning the middle term, and then the multiply to find c, which is your third term. So we look and we're like, okay, the only possibility is going to be 3 and 4, because 3 plus 4 is 7. 3 times 4 is 12. And then these are the two solutions, and you can literally plug. So basically we're saying if this was equal to 0, these are both equal to 0. And then there's a property, the property of I think it's called the zero property, zero factor property. I have to actually look it up. Sometimes, these math terms, we don't use them every day. So that's why it's just, again, so awesome that they're getting this level just, at their age, but they're learning it in a non-stressful environment. So, but basically you're saying either this or that equals 0. So if this one equals 0, then x has to be -3 by algebra. If this one equals 0, x has to be -4. And then it even goes into this method called completing the square to find those solutions. And that's just awesome too, because completing the square is such a difficult concept for some to grasp. So walk through those steps. Basically, you're just dividing the middle term by 2 and squaring it, and then you add it to both sides. And it creates what we call a perfect square, but it's not taking you through that whole process. It's just giving them the first step. It's introducing. Okay. I'm not going to go deeper into that, but just know that that part is really important. It's not important that they're like, I get this, but it is so important that they see that process and are just seeing the flow of it. Then I just had to point out, this is the last thing we're going to do in this video, because again, a lot of this stuff, don't be afraid to use that answer key and let them see the process of what they're trying to do. And, on page 3, it's just brilliant. It's like common errors at the bottom of the page. It's showing common errors that can happen. Like, negative x squared does not equal negative x squared. It's just one of them. So they walk the process. So what does this mean? This means negative x squared, because it's implied that the squared is just with the x here by notation. Here it's implied that the negative is inside with the x. So this, you're just following that through here. And then what happens is this is x times x on the inside. So this is negative, and it has 2 steps. So this is negative x squared. And this is positive x squared, because negative x times negative x is positive x. But negative x times x is still negative. So you can see how that would be a common error, and we see it all the time in higher levels of math where students forget. They don't remember, oh, that negative is included inside the parentheses, so it's eliminated when we square it, versus if it's outside, it carries over. So work through that, because there's a couple of cool examples. And this last thing I'm going to say is this GIMA, G-I-M-A. I was like, what is that? I Googled it, never heard of it. So I don't know what that is. And I finally found it on the inner part, where it has those little you guys probably, those in challenge, know better than I do, because the packets print for the younger ages don't have it, but it's these little blue pages inside, and it shows what Gimma is, and it's so cool. They say, when I need to simplify, God is my answer. And I was like, so God is my answer is Gimma. So some of you may be familiar with PEMDAS, and this meant please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. Now I'm going to tell you, multiply, divide, this order doesn't matter. Okay, you can divide and multiply. Add and subtract, that order doesn't matter either, but you got to make sure you track your negatives properly. So add, subtract doesn't matter, but you always have to handle things in parentheses first, then things with exponents, and then you move on to those two. So many have now, I was noting on Google when I searched, and I didn't realize this either, they've done GEMS. Grouping, exponents, multiply, subtract, which subtract, like, I get it, they're trying to come up with a cool acronym. Technically, I like, if you're going to lump addition and subtraction together, I'd rather see it lumped as addition, because the act of addition is that you can explain it's combining. So sometimes you're combining negatives, sometimes you're combining positives, but we're not just only subtracting. Sometimes we have to subtract if the signs are different. Sometimes we have to divide instead of multiply, but dividing is just multiplying by a fraction. So it's easy to attribute. But the big thing is groupings, because there are going to be times like we're thinking about parentheses all the time, but what about if you have absolute value? X minus 3 and then plus whatever. Or when it's an X, it's a little different. But like if we're just simplifying numeric expressions, that was kind of a mistake on my part. I have to simplify this before I add the 4 or multiply the 6. So this would be grouping. So it's a little more inclusive. So grouping for Gimma is the God part. Then I, what's the I? I is index. So if you look deeper in the book, you'll find that index is another word for exponent or the power of. So Gimma, you handle your grouping first. So if this was like 6 squared, we'll just do this real quick and then be done with the video. So you would handle the grouping first. So you have 6 squared, this equals 6 squared, and then this inside, we're going to go ahead and turn it to parentheses now, because this is going to be a positive number. So 5 minus 3 is 2. So that's just times 2, and then plus 4. Parentheses with just one number, remember, is times. So now I have to handle my index or my exponent next. God is, so 6 squared is 36 times 2 plus 4. Okay, now my M for multiply, we would handle this next. So we have 72 plus 4. And now we handle our answer, A, add, and we get 76. Okay, so that is the process. If you still like PEMDAS, that's fine. But I did think it was really cool that they came up with their very own acronym that relates us back to God, especially when I need to simplify. God is my answer, because so many of these things, like when you look at that, it's very chaotic and confusing. Well, God is my answer, and if we always remember that, we're gonna bring it in and focus on one piece at a time and in the appropriate order. So that's all I have for pages 1 through 4. Look for another video or two. I'll cover at least through pages 8, because there's some other great things in here, and they'll be posting in the next day or two. So have a great day. Thank you for joining.